welcome to Cloud on Air, live webinars from Google Cloud. We are hosting webinars every Tuesday. My name is Gabi, and today I'm here with David, and we will be talking about why you need graph technology on Google Kubernetes Engine. You can ask questions anytime on the platform, and we have Googlers on standby to answer them. Let's get started.
My name is David Allen. I'm a partner solution architect with Neo4j. After this presentation, you're welcome to reach out to me on Twitter. This is my Twitter handle and my contact information. I have a really fun job because I get to play with all of the newest stuff like on Google and also get to work with graphs, which we're going to be talking about a lot today.
Hi, I'm Gabriela, but you can call me Gabi. I'm a developer advocate for Google Cloud, working on storage and databases. Differently from David, I like SQL, but you can reach me at Twitter at Gabi Davila after the presentation too. And I'm going to start talking about Google Cloud a bit. Google Cloud advantages and the power of Google Kubernetes Engine for managed applications. Then David's going to talk about graph databases and deploying Neo4j on GKE, plus showing a bit of a demo too.
Absolutely.
So, why companies are moving to Google Cloud Platform? First, they want to manage their costs more accurately, improve reliability, and scale more smoothly. Second, they wanted to get more value off their data. Third, to more rapidly build applications and be able to connect to other platforms and services. All of that having increased productivity on teams and security connect to other devices. When we created the cloud, we thought on three fundamental principles. Infrastructure and security and networking is one of the base. Then unlocking data and accelerating the development of our systems. And being open and more enterprise friendly to be more cost efficient. Google has today 18 regions and 55 zones. Each region has 3 zones. That's because of availability, backup, and disaster recovery. So if one zone goes away, you have another 2 to be able to have your application if you didn't even deploy that globally. On the past 3 years, Google invested around $30 billion just in infrastructure and networking. This is a map of our networking and submarine cables. On the past 3 years, they created 7 new submarine cables and hundreds of miles of networking. Right now, Google's infrastructure is private. It's seen as one of the top 1 in the world, and it's estimated by third parties to have 40% of the internet somehow going through our infrastructure on a daily basis. But Google has developing network and containers for the past 12 years. Our applications run on containers. Gmail, the search, the maps, Colossus, which it is our file system, and our VMs also run on containers. Everything inside a container. How many containers we launch? About billions per week. People say that maybe 2 or 4 billions, but I don't know exactly. But it's on the house of billions of containers per week. That's a really high number. However, managing one container is easy, but about 1,000. When you have a scale, you can easily, on Google, have that management. But if you're doing it yourself, you need to worry about the deployment, how you're going to monitor them, how you're going to do patching, how you're going to know that one service is connected to the other, how they won't interfere with each other. And beyond being modular, they also need to know what the others are doing so they can keep their relationships going on. This is all here is controlled, needs to be controlled, but at scale. And that enters Borg. Borg is Google's own container cluster manager. It manages all of Google's applications and machines. It has jobs running for web applications and even high database workloads like for big table and called Spanner. MapReduce also runs on Google Cloud on Borg, and Borg is working in a more declarative way. You tell what you want it to do, and it does it for you. You don't need to create a script telling step by step which instruction you're doing so you can have your application deployed. That's why we created Kubernetes. Kubernetes is based on Borg, but it's written in Golang, and it's 100% open source. Supports multiple containers, and it can run even on your computer or any bare metal server that you have. It's managed by Google, and it has a release approximately every 3 weeks. So I recommend you to keep an eye on that. And I'll be passing for David.
So one of the things that we find with the GCP marketplace is that they've made it now very convenient to deploy Kubernetes apps directly onto an existing GKE cluster using the marketplace. Basically, it's a quick install and configuration type of experience where you track things at the application level rather than thinking of them as a set of Kubernetes resources or just a big pile of containers. This kind of brings us to graphs. So before we talk a little bit more about Neo4j on GKE, we have to motivate that by talking about graph databases and why they're important and how they represent information in your domain. At its core, Neo4j is a graph database. We find that in the real world out there, everything is connected into the form of a graph. If you consider people, places, and events, they have complex webs of relationships that connect them together in meaningful ways. Whether that's companies and markets, countries, histories, and their politics, or sciences, the art, and teaching. Just about every domain that you look at is this densely connected domain where you have real things in the world connected by relationships. Some of our financial clients take this and look at financial transaction networks in terms of graphs and find criminals and fraudsters as well as behavioral patterning in their data. This also goes all the way to software code and its dependencies. To give you an example of some use cases where Neo4j and where graphs themselves are really powerful, we have kind of two categories. Within internal applications inside of a company, Neo4j gets used a lot for master data management, where if you think about taking all of the metadata from the different systems in your organization, putting it into one related graph, and being able to talk about how the data in one system relates to the data in another system, whether that's mappings, transformations, and an ETL pipeline, what have you. Neo4j is also frequently used for network and IT operations. Imagine the graph of the infrastructure within your company, routers, servers, networks, and then being able to ask complex questions like, if this particular router fails, what are the downstream implications of that for the rest of my architecture? We're also heavily used for fraud detection, where what you're looking at is a network of people and the financial transactions that connect them, and asking about patterns of flow of money. For example, if I give Gabby $5,000 and the next person $5,000, but they both shuttle it on, you need to be able to step back and see the broader pattern in the graph of a flow of transfers in a particular direction. On consumer-facing applications, Neo4j is frequently used for real-time product recommendations online. Think of a social graph where retailers might recommend what you might like to purchase on the basis of who else in your social network has bought what. Neo4j gets used for graph-based search in much the same way, and for identity and access management, where users, their roles, and permissions are represented as a graph. Neo4j also has a history of transforming large enterprises for over 14 years. These are just 3 key examples. For one of the Fortune 50 retailers, Neo4j does real-time promotion recommendations. This helps our customer drive record Cyber Monday sales. We're talking about 35 million daily transactions, where each transaction might be 3 to 22 hops through the graph. Neo4j needs to be able to guarantee that at very high execution speed, where queries get executed in 4 milliseconds or less. With this one particular customer, Neo4j even replaced IBM WebSphere. For Marriott, Neo4j powers parts of their real-time pricing engine that does 300 million pricing operations per day. Marriott found that they get 10 times the transaction throughput on half of the hardware compared to Oracle. This is all accounting for the fact that the information is structured as a graph and is more readily queryable in that structure. They ended up replacing their Oracle database. And for one of the largest postal services with over 500,000 employees, Neo4j handles real-time package routing. We route 7 million packages daily at peak, with 5,000 routing operations per second in some cases. So chances are good that if you've booked a hotel or a flight online, or you've received a package in the mail, you have interacted with an enterprise that's been using the Neo4j graph platform. How is this information structured, though? Property graphs, the name of the data model that Neo4j uses is property graphs. It's very, very different from relations that you might be familiar with. Property graphs consist of nodes, relationships, and properties. Nodes are real objects in the graph. They're people, places, things, and they can be labeled. A relationship relates to nodes by both a type and a direction, and properties are simple name-value pairs that go on nodes and relationships. So on the right here, we see a simple example of a property graph. What this graph is saying is that there's a person named Dan who was born in May of 1970. Dan loves Anne, who was born in 1975. Anne loves Dan back, and they live together. We can tell because there is a relationship lives with between Dan and Anne. Now, Anne owns a Volvo V70, but Dan drives it. This kind of a flexible property graph model lets us say all of that in a simple picture and allows us to annotate that with a set of relationships and with properties on those relationships. So, for example, we can assert that Dan has been driving the car since January of 2011. So when we talk about graphs and you think about Neo4j, it all comes back to these property graph components: nodes, relationships, and properties. Now, one of the great things about the property graph model is its sheer whiteboard friendliness. When we work with new customers, sometimes what we go in and do is start a simple elicitation session where we talk to them about their domain and get them talking about what it means to them and what's important in their domain. It's very natural for people to get up and whiteboard a concept out and to draw bubbles and lines connecting things. It's a great way of modeling direct representations of how people are thinking about their domain. Let's take a simple example. So suppose that we got together in a room together and we sketched up a system for storing movie and actor information so that we could, for example, recommend a good movie to a friend. We might start with some bubbles like Tom Hanks and Hugo Weaving, who are actors, and we might connect them to the movies that they're in. The reason we would have such a data model is to drive recommendations later. If you like Tom Hanks movies and you liked Cloud Atlas, then you might also like some other movie that Tom Hanks has been in. So you get people whiteboarding, and they end up drawing a structure like this. Just nodes and edges, bubbles and lines. Translating that to a property graph model is very straightforward. We just treat every single bubble on the screen as if it's an actual node in a property graph, and we treat those lines that we got as relationships between them. We punch those up with labels. So for example, we might label Tom Hanks with the labels person and actor, indicating what kind of a node he is. And then we might put properties on the relationships as well. So when Tom Hanks was in Cloud Atlas, he played the role of Zaki, and Hugo Weaving played the role of Bill Smoke when he was in Cloud Atlas. The result is basically a finished property graph model that can then be directly created in Neo4j. And so when we were doing this, we were doing the data modeling on the whiteboard. We were capturing metadata, and then what ends up in the database is just what we sketched. That's what we mean by whiteboard friendliness. That brings us to Cypher. So Gabby said she's a fan of SQL. Now, one of the things that I love about SQL is that it is a declarative query language. Okay? A declarative query language is one where you don't tell the database how to go get the information. You simply say what it is that you're looking for, and it's the database's problem to go figure that out. Well, Cypher is just declarative query for graphs, akin to SQL. So what you do here is you write a pattern that almost looks like ASCII art, right? And then you just say match and return, and you use a couple of other familiar SQL constructs like where and like and limit and skip and so on. So in this particular query, what we're trying to do is we're trying to match a node that has the label person and that has the property name whose value is Dan, and then we're looking to traverse a loves relationship to some other node that we don't know. we're going to bind that second node to the variable whom and return that whom. And so from our previous graph, we know that this kind of a query is going to result in the node Ann, because Dan loves Ann. So now that we've covered the basics of property graphs, now that we've kind of motivated what a graph is and why it's useful, let's talk about how to deploy this on GKE and what that architecture looks like and get into some technical specifics. So first of all, if you'd like to try this for yourself, it's on GKE, it's on the GCP Marketplace right now. You just go to the Marketplace on the left-hand side of the Google Cloud Console, and you type in Neo4j Enterprise at the top. You're going to find that Neo4j offers two items in the Marketplace. One is a VM-backed solution, and the other is a Kubernetes app. Today, we're talking about the Kubernetes app. You can filter to that on the left-hand side and find that tile that says Neo4j Enterprise Causal Cluster, which is a Kubernetes app. What is that going to do for you? Okay, so when we speak about Causal Cluster is Neo4j's highly available clustered architecture. On the right-hand side here, we've got a picture of what that looks like. So causal clusters are divided into two kinds of nodes in the cluster, core servers and read replicas. Core servers synchronize the data and guarantee high availability. In order to protect your data and guarantee the ACID constraints, a transaction won't be acknowledged until it's written by at least two of the three in a three-node cluster. Read replicas can be spun up and spun down as needed to handle analytic workloads or to handle heavy read loads that you don't want to tax the core servers with. Now, when you go and deploy Neo4j on GKE, the marketplace configuration options basically boil down to a couple of simple parameters that you pick. You're going to indicate how many cluster nodes you want of each type, and you're going to specify hardware requests and limits on your Kubernetes cluster for how big it can get, and disk type and disk size, and so on. So here's an example of what that's actually going to look like. When you click deploy on the marketplace listing, you're going to be asked to say what cluster do you want to deploy this onto, what Kubernetes namespace do you want to use. You will assign it an app instance name, and you'll have to select a number of core servers to use and a number of read replicas. What you're seeing right here on the screen are the defaults. Typically, folks start with 3 core servers and 0 read replicas, and they may change that over time. You're definitely going to want authorization for your cluster, and then you can specify the CPU, memory, and CPU limits, both the initial requests and the limits, as well as a few other parameters. Now, on the right-hand side, as you go through this, you're always going to have links to the user guide, Neo4j's official documentation, and other resources. The terms of service for launching this is what's called BYOL, or Bring Your Own License. If you're an existing enterprise user of Neo4j, you are permitted to launch this. If you don't have an existing license with Neo4j, trial licenses are available through the Neo4j website. So suppose you go through that and you deploy Neo4j. What are you going to end up with? Well, on the Applications tab within GKE, you're going to see an entry that is the name you deployed. In this case, I deployed something called MyGraph. And you'll see that its status is OK. On the Workloads tab, you'll be able to break that down and see what actually got deployed as a result of that application going out there. So let's quickly talk about the architecture of how that breaks out. Earlier, we talked about how there is a set of core nodes and a set of read replicas. In Kubernetes terms, these get modeled as stateful sets. So if you choose 3 core nodes, you're going to end up with 3 pods in a stateful set. Each one of those pods makes a persistent volume claim out to a GCP disk. That disk is going to be backed by the size and the storage type that you chose when you deployed the cluster. You're going to get a stateful set for read replicas as well. That can start at 0, or it can be whatever number you chose. Now, in that Kubernetes deploy, you're also going to get some secrets. When you first launch, Neo4j is going to assign itself a random strong password, which is stored inside of a Kubernetes secret. And there are a number of other settings that you can customize as well. For example, pod disruption budget and some other things. So databases on Kubernetes are substantially different than some of the stateless microservices that folks are used to deploying on Kubernetes. If you have a database, its fundamental job is to store data and be stateful. And so that means we need to be thinking about things like backup and restore. The approach that we've provided is in this GitHub repo, we give you utility containers that you can then apply to take backups live. And so this is what that's going to look like. You're going to specify a little bit of YAML, apply that to your cluster, and the utility container runs, takes a live backup from your cluster, compresses it, and sends it off to Google Storage. So it's basically as simple as applying a resource, waiting a little bit of time, and then out pops an archive on a Google Cloud Storage bucket that you specify. In order to make this work, what you have to provide is the pod or service endpoint address, the bucket name where you want the data to show up, and a service account key that has write permissions to that bucket. Actually taking the backup is as simple as running kubectl apply backup.yaml, or to do the exact same thing on a cron job. So if we've got backups, we're going to need a way of restoring those as well. And so this is a similar approach. But rather than a separate container that we run on Kubernetes, this runs as an init container. So the utility container that we provide runs as an init container just before a Neo4j pod starts. And what that init container does is fetches a backup from Google Cloud Storage, uncompresses it, restores it, stages the data in the right place, and then when the Neo4j pod starts, it finds the data that it needs. And this is an example on the left-hand side of the YAML that you can use to do that, which can be found in our GitHub repo. In order to do this, all you need is a backup set that's hosted in Google Storage and a service account key that has read permissions to that data. So GKE has a built-in way of allowing you to scale these stateful workflows. Because it's a stateful set, you can use the scale feature in GKE to add a read replica or add a core node if you wish. This just works out of the box. But we should say that clusters, because they fundamentally need to retain state, they need to synchronize with one another so that they're all at the same point in the data. And so typically, if you would scale a database in this way, you should be taking this new node and scaling something that restores from your latest backup first. That in turn minimizes the amount of catch-up that the new node needs to do with the rest of its buddies in the cluster in order to come up to speed. The thing to keep in mind about scaling these database nodes is that scaling places extra load on the rest of the cluster as that new node that just popped into existence catches up with the other nodes in the database cluster. This is why you want to do that from the latest backup when you start it. So if you've got this backup approach and you've got a restore approach, then essentially you've got a way of implementing replaceable stateful clusters. You do regular full backups to Google Storage, and you have some custom templates that go to where you're doing your backups. You know how to create something new from a seeded backup, and then you can replicate an entire environment, for example, for a dev test prod split, or you can use this for quick recovery in the event of operations issues. If the cluster, for whatever reason, encounters problems, you can execute the entire thing and start a new one from the latest backup, and you're back up and running in minutes. Now, if the things that we've provided for you in the marketplace are not enough, you can customize any of this as you go. So the GitHub repo that is linked here contains all of the original Helm charts that were used, as well as the ancillary containers, such as testing, backup, and restore, and some stress testing type stuff in there. So if you want to change the way Neo4j is configured, add your own plugin, all of that's possible by taking a look at that link and using the YAML that you'll find there. So suppose you deploy a Neo4j database on GKE. What are some of the cool things that you can do with it? Well, Neo4j has been working for some time on something called the Grand Stack, which is a combination of GraphQL, React, Apollo, and the Neo4j database. And so the Grand Stack is basically the ability to write applications that fundamentally use graphs. So front-end technology development is going in this direction of heavy reliance on GraphQL. That means you need a back-end component that serves up data according to the GraphQL spec. What better way to serve up graph data than to back it with an actual graph database? So clients issue GraphQL queries. That GraphQL query gets translated into Cypher, hits Neo4j directly, and a response goes back to the client. This can work with both read and with write queries. So in this case, what we're saying is that you have Neo4j running in GKE. You have Neo4j GraphQL.js, which is linked on this slide, which is running in Docker on top of GKE as well. That gives you your data tier and your backend. you can simply deploy a React application as an SPA or single page application as simple static files in Google Storage Bucket. So using this kind of an approach, you can start with GraphQL type definitions, and you can get a back end running very quickly that's attached to graph storage, a perfect match between GraphQL and the Neo4j. So let's go in quickly and take a look at how this stuff looks. So earlier, I have deployed my mygraph cluster. I can click here on workloads, and I can actually go in and see any of the individual components, such as my core nodes in my stateful set, as well as the individual pods underneath, as well as the logs that go to Stackdriver because we're running in such a nice managed Kubernetes environment. Now earlier I set up port forwarding so that I could actually talk to my cluster via localhost. What we're looking at right here is the Neo4j browser environment. This is basically a shell type of experience where you can run Cypher and where you can visualize results. And so we've been talking about movies. So I put into this graph a simple movie graph. Let's expand that out. And you can sort of see I run a really simple Cypher query, match n, return n. That just gets everything that's in this small sample database and maps it out. And so we've got movies colored in blue and people in those movies colored in orange, and we can flexibly relate those. Neo4j can also be used with Neo4j Desktop when you're running it in GKE. Neo4j Desktop is a tool that you can freely download from our website and that allows you to launch local databases running on your machine. You can also, however, add remote graph connections. And so in this particular case, I've added my Neo4j on GKE here, and that in turn allows me to run graph apps, which are miniature graph applications tied to that database. And so I can say, for example, p person name I can find Tom Hanks as an individual node and then expand out from him or run whatever kind of Cypher that I need to from there. Neo4j has also, not too long ago, released a new graph app called Bloom that is for more exploration of your graphs. I don't know if the network is going to cooperate with us here today, but Bloom can be used to issue natural language type queries. Let's add a new scene in Bloom. And up here, rather than writing Cypher, we can use more friendly human language patterns like person named Tom Hanks. And it interprets that as a particular Cypher query and can load that data for us. We can blow up Tom here, click on him and hit Command E to expand his immediate neighborhood. We can, let's focus on You've Got Mail and Joe versus the Volcano and expand only those movies. And we can kind of quickly see who Tom Hanks probably knows and what kind of movies they have in common. And we're going to find Meg Ryan is one of his frequent co-stars. Expanding Meg gets us another link between Tom and Meg, the movie Sleepless in Seattle. And so Bloom is this really fun and flexible way of exploring graphs and specifying more human language parameters and finding the data that you need quickly. All of this is backed by Neo4j running in containers launched on GKE. And so, please stay tuned for the live Q&A. We will be back in less than a minute. So it's time for some Q&A. We've gotten a number of questions. Let's start off with this one. Gabby, how is GKE different from open source Kubernetes?
Technically speaking, it's not very much different from one another. What helps you is GKE, you don't have to worry about the servers itself. On Kubernetes, open source, you may have to worry about deploying another cloud and spinning up the environments and the service itself, and or running even on-prem is a bit more complicated because you need to take care of your network, and GKE allows you to not have to worry about that kind of stuff and plugs directly to other Google services way more easily than open source Kubernetes elsewhere.
So we got another question. How do other apps deployed in Kubernetes access the database and the data in it? Is there an equivalent to something like JDBC access? And yes, there is. So Neo4j implements a binary protocol called Bolt. And so if you have an application that needs to talk to the graph database and issue Cypher queries, it uses the Bolt protocol. On Neo4j's website, there are drivers available for every major language. So it's really straightforward to make a connection and start issuing Cypher and getting the answers back. All you need to do is have the service endpoint.
David, will the marketplace help me if I want to deploy other side containers, or how can I do that?
So for sidecar containers, the marketplace right out of the box won't help with that. So the marketplace has a very smooth kind of a user interface for simple cases. If you would like to add a number of sidecars onto your deployment, that's where we provide the Helm charts through the GitHub repo, so that's very easy to do. And then once you look at the structure of that repo, it's very straightforward where to add them. But the marketplace out of the box won't let you specify that sort of thing.
When would I need to scale a Neo4j cluster?
So usually what we recommend with clusters is that before you launch it first, you think a little bit about how much hardware you're going to need so that you end up with the right size of core nodes. I think one of the most common cases where you'd want to scale a cluster is, say you have a database that's under a heavy transactional workload and it's taking writes in all of the time, but you also want to run some heavy analytic process against it. Neo4j offers an open source package called Graph Algorithms, where you can run community detection, page rank, all kinds of different complex graph algorithms. Those sorts of heavy processing operations are not something that you'd want to hit your core cluster with. So you might, for example, add a read replica so that you can beat it up with a high query load doing some graph algorithms, and then when you're done, spin it back down again.
And how would you upgrade versions of Neo4j on GKE?
So right now in GKE, it's not a fully managed experience. So that's another case where over time we're going to maintain the current version of Neo4j in the marketplace. So you have a couple of different options. You can launch a new cluster and restore from a backup, or you can tune that to whatever your internal needs are. But in and of itself, to upgrade an individual node within Neo4j, the database process is the pod process. So you don't upgrade the software within the pod. Rather, you kill the pod off and add a new one at the newer software version, and it catches up with the cluster, and there you go.
Okay. Stay tuned for the next session, CETV, Tables Journeys with App Dev on Google Cloud. Thank you.
Thanks.